This simulation is going to help us to understand how pressure, temperature, and volume are related. So we have two different cases here. So in the case on the right, you have a gas tank, so the volume here doesn't change. And then you have, let's say, air inside this gas tank. And on the left, what you have is a piston. So what that is you have a cup, and then you have a movable lid. And inside that movable, so inside this cup with the movable lid, you have gas atoms again here. So here, the lid can move up and down. And so what's going to stay this, well, we'll worry about that in a little bit, but let's concentrate on first is look at those gas atoms. So in both of those cases, inside the gas tank and inside this piston, they're on average both moving at the same rate. What that means that in both cases here, the gas atoms are at the same temperature. So let's increase the temperature for both of them. So if you notice, as you increase the temperature, the gas atoms move faster. And as you lower the temperature, the gas atoms move slower. So that's going to be the first case. So just the rate of motion, that's going to represent the temperature of the gas atoms inside those two different kinds of containers. So now let's concentrate on the container on the right. So here, the container on the right, its volume is going to stay the same as we increase the temperature. So let's see what happens to the pressure in this case. So you can ignore the one on the left for now, just concentrate on the one on the right. So as we increase the temperature, you notice that the volume remains the same. The volume stays at 1, but the pressure increases. It goes from 0.4 to whatever the given units are to 2. So the pressure increases. And the reason why the pressure increases is because you keep the volume constant, and those gas atoms, because they're moving faster, they're exerting, they hit the wall with more force, and that force is spread out over that area, which means that the pressure is going to increase. So that's the first case. If you keep the volume of a gas constant, then as you increase the temperature, the pressure has to increase. So that's the first case. If the volume is constant and you increase the temperature, pressure is going to increase. And also, if you keep the volume constant and you decrease the temperature, then that means that pressure is going to decrease. So that's the first case. Now let's concentrate on the one on the left. So on the one on the left, this is a piston. So what's happening inside the piston is that because the lid can move up and down, what's pressing the lid down is the air above it. And the air above it, that's going to remain at air pressure. Or what that means is that the pressure on this piston is going to remain constant. So you'll notice that the pressure is going to remain at 1 here. So in the case of a piston, where you have if the pressure remains constant, let's see what happens in this case. If you increase the temperature, that means that the gas atoms are impacting this piston with more force, and they're able to push the piston upwards. And what that means then is that the volume of this piston is going to increase. So the other case is that if you have a gas and you keep the pressure constant, then when you increase the temperature, that means that the volume is going to increase. And vice versa, if you keep the pressure of a gas constant and you decrease the temperature, then that means that the volume is going to increase. So these are two separate relations, but you can combine them both into one equation that we'll be looking at. But again, the idea is that if you keep the volume constant, you increase the temperature, then that means that the pressure is going to increase. And on the left, if you keep the pressure constant and you increase the temperature, then that means that the volume is going to increase.